In the previous lecture, we have started with the transcendental equation, and then we have solved the transcendental equation with the help of Newton-Raphson method. Okay, now we'll go to the next called as Regula Falsi method, or we can have the another name for this method is the false position method. Okay, so we can have the Regula Falsi method, or we call it as the false position method. I hope you can see this journal, right?
Yes, sir.
Okay. So here we have the Regula Falsi method, or we can say this method is as false position method. Okay. So what we have seen in the Newton-Raphson method is Newton-Raphson method uses the tangent. Okay, whereas this Regula Falsi method uses the chord. Okay, the chord joining to the two end points of the given curve. So whatever the given curve we can have, if we join the two end points of the curve, that chord is used by this Regula Falsi method, and then we find the point of intersection as our next iteration. Okay, but the preliminary conditions remains same. Okay, so what we can have, like f of x is equal to 0, be the given equation. Yeah, it's going to be the given equation defined in the interval a to b with what is the criteria for the root? We must have one value less than 0 and other value greater than 0. Okay, so then we can guarantee that there exists a value in between a and b such that f will be 0, and that is our point of interest, that f value is going to be 0 at that particular point. Okay, then what is the Regula Falsi method? So we have, what will have here, the iteration. Okay, x is given by, okay, so we have a f of b minus b f of a upon f of b minus f of a. Okay, so this is the formula for the iteration by the Regula Falsi method. Okay, so you can see here what we need. We need a, we need b, we need f of a and f of b. So these four values are needed to find the next iteration. Okay, so this will be more clear when we'll go with the example. So is there any doubt in this method?
Sir, can you scroll up a little bit?
Yes, surely. Yep. So here we know this f of x is equal to 0 is a polynomial equation or is a transcendental equation. So any equation that we want to solve, we want to find the root of this equation. Okay, so we want x such that f of x is equal to 0. And this is defined in the interval a to b, where we know that f of a is less than 0 and f of b is less than 0. Then we know this x is equal to, okay, a f of b minus b f of a upon f of b minus f of a is the root of given equation. So this is going to be the root, and this is the formula for the Regula Falsi method, or we call it as false position method also. So is there any doubt up to it?
No, sir.
Okay. So we can go for the example by we'll try to solve using this Regula Falsi method. Okay, so let's try to have the example. Okay, so I hope all of you are able to see
So,
this. Yes.
so we can say this regular Falsi method is more accurate than Newton-Raphson's method to find the root of the equation. Because in that we just approximate to a certain decimal place, like it will be closest to this.
No, this is also the approximate value. Okay, all numerical methods will give you approximate value.
So, but
Okay.
here we say that x is the root of the equation, right? In Newton's method, we have to continuously keep on putting values.
Yes, this is also the approximation. This is not the perfect root. So this
Okay,
is
sir.
the approximate value. All numerical methods will give you approximate value. Okay.
Yes, sir.
Yeah. Okay. So here we have the example. Okay. Find an approximate value of the root of the equation x cubed plus x minus 1 is equal to 0 near 1. Okay. Using method of Regula Falsi. So we have to use the Regula Falsi method, and then we have to find the approximate value of the root. Okay, all numerical methods will give you approximate value. Okay, so let us try. The hint is given to us that near 1. Okay, so it is in between 0 to 1 or it is in between 1 to 2, that we have to still find out. Okay, so let's go for the solution. We can have. So we'll go with the solution. Let f of x is equal to x cube plus x minus 1 is equal to 0. Be the given equation. Okay, this is the given equation. So we have to find out the interval. We have to find out a and b. Okay, then we have f of 0. So let us try with f of 0. What happens with f of 0 is going to be minus 1 less than 0. Is that okay?
Yes, sir.
And now consider f of 1. So what is f of 1? It will be 1 plus 1 minus 1. So that's going to be 1, which is greater than 0, right?
Yes,
So
sir.
at 0, the value of this function is going to be minus 1. And at 1, the value of this function is going to be plus 1. Okay, so that means in between 0 and 1, this function, we know it is going to be a continuous function. So this function attains the value 0. And we have to find out the point where it attains the value 0. Okay, so here we can say that the root, hence the root is in between 0 and 1. Okay, so the root is in between 0 and 1, and hence we can say by Regula Falsi method. Always mention the method that you are going to use. So what we have, the first approximation is, see, we have the formula a f of b minus b f of a, and we have f of b minus f of a. So here what we have, okay, here a is equal to 0 and b is equal to 1. Okay, because root lies between a to b. So here a is going to be 0 and b is going to be 1. Okay, so let us try to calculate what is the value. Okay, so this is equal to a is 0 into 1 minus b is 1 into minus 1. And this is what we'll be having, 1 minus minus 1. So we can say this is going to be 1/2, which is going to be 0.5. So we got here x1 is equal to 0.5. Okay. Now we have two intervals. Okay. So here we got two intervals now. This is a, which is 0, This is B, which is 1. And now we calculated the point x1, which is 0.5. So now we have to think the root lies here or here. Okay. We know here we are having negative value. Here we are having positive value. So we have to decide whether it is negative. You need to understand that always the value of f of x is equal to 0 lies between the negative and positive. Okay, so if this is positive, then the value lies between a and x1. If this value is negative, then the value lies between x1 and b. Okay, so to understand this, which interval we have to choose, a to x1 or x1 to b, we need to find the value of f of x1. So let us find out what is the value of this function at x is equal to 0.5. So what is the function we have? X cube. So it is going to be 0.5 cube. Then plus x. So it is 0.5 and minus 1. Okay, so this is what the function is, x cube plus x minus 1. Okay, so we got here 0.5 cube plus 0.5 minus 1. So what we can have 0.5 cube? So it is easy. We can have 0.125 plus we have 0.5 and this is minus 1. What is the value of this function? Please calculate with me because I hope
minus
Minus
0.375.
minus 0.375. Okay, is it greater than 0 or less than 0?
less than 0.
Surely it is less than 0.
Yes, sir.
Yes, it is less than 0. So what we got here, this is going to be negative. Okay. So now see, here it was minus 1 and here it is minus 0.375. Which of this is closer to 0?
0.375.
0.375. That means our root lies here and this interval is discarded from A to x1. So the root lies between x1 and b now. Okay, because x1 is negative but closer to 0 as compared to a. Okay, and so we write here the root. Okay, so we can say the root is in 0.5 to 1. Okay, so root is in this interval. We can see 0.5 to b. So 0.5 to 1. Okay. Now we have to again use this formula and find out what is the value of x2.
Sir,
Okay. Yes.
so can you please explain it again that why that interval is rejected and accepted?
Yes. Yes, surely. Okay. See, here at the 0, we get negative value of function. Is that okay?
Yes, sir.
At again x1, we are getting negative value of function. Is
Yes,
that okay?
sir.
Okay. So if we consider the graph of this function, okay, at 0, it is minus 1. Okay. And at 1, it is plus 1. Okay. So we can draw the graph like this. Okay. So I'm just drawing a continuous function from this point to this point, nothing else. Okay. So this is the continuous function, right? Here
Yes, sir.
we have the value 1, 1. Okay. And here we have this value. This is going to be 0, minus 1. Is that okay?
Yes, sir.
Okay, now see what we got. We got the point x1 here, 0.5. Correct? So now at 0.5, what is the value? It is minus 0.375. Is that okay?
Yes, sir.
Okay, see, now this is negative, this is negative. But can you see, this is the actual root we want to find. Okay, here we have to reach actually. Okay, so our point of interest is this point. Okay, so now tell me, in this interval 0 to 0.5 and 0.5 to 1. Okay, so here, is there any chance that we'll get f of x is equal to 0 in the interval minus 0 to 0.5?
No,
Because
sir.
both are negative, no?
Yes, sir.
Okay, so both are negative, sir. That means there is no chance that it will cross x-axis. Okay, so
Yes,
that's
sir.
why this interval is rejected.
Okay,
Got
sir.
it?
Thank you.
That's why this interval is rejected, as this value is closer to 0. Okay, and this value is far from 0 as compared to this value. So this interval is rejected, and hence there is a chance that the f of x will be 0 in this interval from 0.5 to 1. And that's why this interval is selected. Got this one?
Yes, sir.
Excuse me,
Thank
sir.
you, sir.
Yes.
Sir, what if the value we are getting is farther from the 0 than at -1?
Okay. Yes, it can happen. So we'll not take that value.
Then,
We
sir,
have to go towards 0.
okay, sir. So the which interval will we take at that case?
See, if it happens, okay, so this value, okay, what we can have, see, we are getting -1 and we are getting +1, okay, at 0 and 1, right? Is that okay?
Yes, sir.
Okay, so by the mean value theorem, okay, this function f of x will be always from -1 to 1. Okay, the value of this function will be in between -1 to 1. Okay, so you cannot have the value -2.
Okay, sir.
Okay, because here this function will take the value between -1 to 1. So you will not have the value -2. Okay, and that's why you will not go away from the 0 than this -1.
Okay, sir.
Okay.
Yes, sir.
Okay, so this is guaranteed by the mean value theorems. Okay, so that's why in the first lecture we have discussed how this is going to have the value in between this only. Got it?
Yes, sir. Got it.
Okay. So I'll write here, this is going to be 0 -1 and this is -1. Okay. Yeah. Is there any doubt? Okay, so we got our first approximation that it is in between 0.5 to 1, and hence we can have x2. Okay, so we have to think of x2. So what x2 will be? This is now new A and this is B. Okay, so we can have, this will be 0.5 into f of 1 minus 1 into f of 0.5. And then here we have f of 1 minus f of 0.5. Okay, so I'll write here for the reference. Here A is equal to 0.5 and B remains same. Is that okay?
Yes, sir.
So now let us calculate. So it is
7 by
0.5
11.
into 1. Yes, wait. Okay, 1 into minus 0.375 upon, here we have 1 minus 0.375. Now let's have this. So we can have 1 plus 0.375.
Sir, 0.5 plus.
This will be 0.5 times 1. Okay, and here we have 1 plus 0.375. So we got this as 0.875 upon 1.375. Okay.
0.6363.
711.
63
63.
and more.
63.
Okay.
So we should take as fraction, right? So it is more accurate.
No, we have to go for decimal points, as we know the accuracy required is 10 raised to minus 4. So we should write 4 digits if are not available more than 4. But if more than 4 digits are available, then we should go for 6 digits. Okay, so here we got the next iteration to be 0.636363. Okay. Now we need to understand again whether this is closer to 0 or not. So we have to calculate the value of f of x2. So we have to calculate what is the value of the function at this point. Okay, and hence what we have, this is 0.6363, okay, cube plus 0.636363 and minus 1. So we got the value at this point f of x2. So f at 0.636363. So calculate this value and let me know what this value is.
So it's minus. So it's
Yes.
minus 1059.
Minus 0.1059.
1059.
1359.
1059.
See, all of only one person can tell me.
1059.
1059. Some more digits.
35.
353.
353.
37. Okay, fine. Okay, so still it is less than 0. Okay, and now let us think of this interval. So we have 0.5 and we have 1. Okay, so this was 1 and now we got this as 0.636363. Okay, so again here we have negative, here we have negative, here we have positive. Okay, so this was 0.375. This is minus 0.105935 and this is 1. So can you tell me where the root will lie?
Between 5 by 11 to 1.
Where root will lie?
Between 0.636363 and 1.
Yes.
And
So
1.
this will be this interval will be rejected. Okay, as both are negative and this is closer to 0. So this interval will be selected. And hence we can say the root is in 0.636363 to 1. So this way we have to keep on updating. Okay, so you can see earlier it was the interval was 0 to 1. Then we updated to 0.5 to 1. Then we updated now to 0.6363 to 1. Okay, and hence what we can have is, so we have the third iteration. So x3 is equal to. Now here what we can have is, here a becomes 0.636363 and b is 1. Okay, so for this x3, a will be this and b will be this. So we got here 0.636363 into 1 minus 1 into minus 0.105935 upon, this is going to be 1 minus 0.105935. Okay, so that's how we can have. Now let us calculate what this value is, and so we have to calculate what is f of x3. So tell me what is the value of this x3? Only one person can tell me. Another can verify that whether
Sir,
it is correct or not.
0.
So it's 0.6711.
0.671195.
0.671195, right? Is that okay? Are you getting this one? Are you getting, all of you are getting the same?
Yes, sir.
Yes, sir.
Okay, so let us calculate the value of function at this point. So 671195 cube plus 0.671195 minus 1. So we need to have this value. F
So
of
it's
x
minus 0.026428.
026428, right?
Yeah.
Minus 0.026428. Is it greater than 0 or less than 0?
Less than 6.
Less than 0. Okay. So again, we have to think. So it was 0.636363 and 1. Okay. So here it was negative. Here it was positive. Okay. And now we got another point. So here point, I can say this is going to be 0.671195, and this is again negative here. Okay, but the value was here minus 0. Earlier it was 1059. 1059 and 35. Okay, and now it is minus 0.026428, and this is positive 1. So which of the interval will accept and which of the interval will reject? This is negative, this is negative, this is positive. So which interval will be accepted?
Minus 0.02642821.
So this is the interval that will be accepted and this interval will reject. Okay, so we can say here, hence the root is in 0.671195 to 1. Is that okay? Are you getting this?
Yes, sir.
Yes, sir.
Good. So we go for the next iteration, that is x4. So what is the next iteration we'll be having? This is 0.671195 into 1 minus 1 into minus 0.026428 upon 1 minus minus 0.026428. So calculate this value. Here again we can say here A is equal to 0.671195 and B is going to be 1. So any one of you can tell me what is the value of x4?
0.679758.
9758. Good. So 0.679758. And now we have to calculate the value at this point. So f at 0.679758. So what this value is? What is the value we can have?
Minus 0.0061455.
minus 0. Just wait. It is 006145, right?
Yes, sir.
Okay.
Yes,
Positive,
sir.
negative.
Negative.
So can I say directly now? The root is in 0.67975821.
Yes, sir.
Yes, sir.
Okay, that's good. Okay. So now again, we have to find out the next iteration. So we can have 0.6797.
When we will do this?
Yes, we'll go for at least 5 iterations. Okay. Or as mentioned in the Newton-Raphson method, accuracy will be mentioned. Okay. So it is going to be 1 into minus 0.006145. Okay. 1 minus 0.006145. So either we'll go for 5 iterations or we'll go for up to the accuracy. So what this value is going to be? Yes. What is value? Any one of you?
Sir, 0.6.
0.6817.
1713.
Yes, sir.
Okay.
It's
So we got this 0.681713. So this is the correct answer after 5 iterations. Okay. So we can say the root of given equation is x is equal to 0.681713 after 5 iterations. Okay, so we can say this is correct after 5 iterations. Okay, so that's what we can calculate. So here, if you try to calculate the value of the function, okay, so what we can have is here we'll get the value of the function more closer to 0 as compared to the previous root. You can even check this. Okay, So check the value of this function at this root. Okay, and you can find that it will be more closer. So you can verify this, what I'm saying right now. So this way we can use the Regula Falsi method to find the root of the equation. So any doubt in this example up to 8?
No, no, sir.
No, sir.
Okay, that's good. Okay.
So generally we have to do 5 iterations.
Yes. So if the accuracy is not mentioned, okay, then we can go for 5 iterations by any method. Okay, in the Newton-Raphson method, always the accuracy is mentioned. Okay, or also it can be asked like go for 5 iterations or go for 6 iterations and like that.
So something like 3 up to 3 decimals.
Yes, the accuracy, if they have mentioned up to correct up to 4 decimals, correct up to 5 decimals, that can be mentioned.
Sir, so like Newton-Raphson method, here also the accuracy will be if the digits are if 4 decimals, then 4 decimal digits are common. Same.
Yes, yes, yes. Even though we can go for more iterations and you can verify that after few iterations, it will also converge. Okay, it will also match. Right now, first digits has matched. So it was earlier 67, 0.6797. So you can see 6797 means it is close to 0.68. Okay, so once you have 68, then it will move closer to 68 and some more digits and like that. Okay. So if you don't have any doubts, then we'll go for the another question. Okay, so we'll go for the another question. Right? Okay.
Excuse me, sir.
Yes.
Sir, in X4, I have got different values, sir, which you have written.
Okay. How much different you got?
Sir, I got value 0.679660 in X4.
In X4, what you got is 0.67
0.9660.
9660. It's okay. Okay, so you are accurate up to 10 raised to minus 3.
Okay, okay.
Okay, so eventually, as we go with more iterations, we'll reach to more accurate answer. Okay. So you can verify your calculations. If you have the same calculations, then there must be some other error. Okay, so error is expected, and that's why we say these are the approximate values. Okay, these are not the exact values.
Sir, but how does in this sum that 5th iteration the second digit only changed?
Yeah.
Yes, sir.
One thing I'll tell you, this factor is decided by order of the method. Okay, so Newton-Raphson method has second order, whereas this Regula Falsi method is of order 1. Okay,
So, sir, error in this method will be more or less?
Error in this method will be more for the same number of iteration. Okay, if we go with the 10 iterations by Newton-Raphson method, and if we go with the 10 iterations by Regula Falsi method, then the error in Regula Falsi method will be more. Okay, whereas the Newton-Raphson method is the faster one than this method.
Sir, can you please scroll up a little bit?
Yeah.
Sir, actually, I have done calculations by using the same values, but I got different answer. Why is this so?
No, I hope please do the calculations once again. Okay, or your calculator may have the different accuracy then. If you are doing the same calculations, others are also doing the same calculations, then you must get the same value. Okay, and if you are not getting the same value, then it is a machine error.
Okay, sir, fine.
Theoretically, you should not get the another value, no?
Yeah, sir.
You are using the same calculations, no? Same figures, same operations you are using. So you have to get the same one. Okay.
Sir, sir, which calculator you prefer? Actually, this calculator is not okay, I think.
No, usually we go with 991 MS, or now they are advanced. They have the ES, I hope. 991 ES they have gone. Any calculator equivalent to this, or you can go with the TI 36X Pro.
Okay, sir, fine. Thank
Okay,
you.
you can go with these calculators. Okay.
Yes, sir, fine. Thank you.
Yes, welcome. Okay. So shall we go for the another example now? Okay, wait. Okay, let's go for the another example now. Okay, so I hope you are able to see this example. Is that okay? Are you able to see this?
Yes, sir.
Yeah. So here in this example, it's mentioned that correct to 3 decimal places. Okay, so earlier it was not mentioned. Now it is mentioned that we have to find out the root correct to 3 decimal places. Okay, so let's go with the solution. Let f of x is equal to x e raised to x minus 3 is equal to 0. Okay, be the given equation. Okay, so we have first we have to find out what is the interval. So we usually go with f of 0. So what is f of 0? You will have this is 0 minus 3. So it is minus 3 less than 0. Is that okay?
Yes, sir.
Okay. So now consider f of 1. So it is going to be e, the value of e is going to be 2.71 something. Okay, so calculate that value. Okay, so we can have 1 into e raised to 1 minus 3, and I hope it will be again less than 0. Okay, so we can have exponential raised to x. So you can type this equation directly in the calculator. And then you can calculate this value directly.
It's minus 0.281718.
Great. Okay, so it's going to be minus 0.2817. Yes. So it is 1718, right?
Yes, sir.
And this is less than 0. Correct. So we have to think of next. So f of 2. What will be f of 2? So it is 2 into e square minus 3. And that is going to be 11.77. Okay, 811. Is that okay?
Yes, sir.
Yes. So we can say, see, we can have one value less than 0. So you got a is equal to 1. Okay. And we got one value greater than 0. So you got b is equal to 2. Yeah. So we can say this value, the function value at 1 is less than 0. The function value at 2 is greater than 0. So that means the function takes the value 0 in between 1 and 2. And hence we can say the root is in the interval 1 to 2. Got this idea? Okay, so the root is going to be in the interval 1 to 2, and hence we can say by Regula Falsi method. We have. Okay, so what we have by Regula Falsi method, we can go for the first approximation as A f of B minus B f of A upon f of B minus f of A. So here we got A is going to be 1. So it is 1 into 11.778112 minus B. So B is going to be 2. And this value is minus 281718. And this all term divided by 11.77 8112 minus 0.281718. Okay. So you please calculate this value and give me the value what is going to be x1. So we can calculate what is f of x1. So f of what is point is going to be 1 point something.
Sir, x1 will be 1.02336.
023
36.
36. One more digit.
003.
0.
0,
Okay.
0.
Okay. So we have to calculate what is the value of 1.023360. Okay. So let us calculate this value. 1.02336. Okay. So answer is going to be minus 0.152471. Is that okay? Are you getting this value? Are you getting the values to be negative?
Yes, sir.
Yes. Okay. So what you can say, whether this is closer to 0 or the previous value is closer to 0. So the value at 1 is minus 0.2 and the value at 1.0 is minus 0.15. So which is closer? 28 is closer to 0 or 15 is closer to 0?
1
1
5.
5.
15 is closer to 0. So that means we have to update the value of A. Okay, and here we can say yes.
So x1 should be 1.023345460.
No, sir, I'm getting the same value as you wrote.
If most of the students are getting this value, then we have to accept this one. Okay. So we can just take one. Okay. Put in the chat what values you are getting for x1.
Sir, I am getting the same value as root.
So we can see this. Okay. Okay, good. Okay. Yeah. Okay. So please see, we are going with the same numbers, same calculations. Okay. So it is expected that we should get the same values. Okay. And if we are not getting the same values, then we have to check the accuracy of our devices only. Because we are not committing mistake, but the device, the machine is committing the error. Okay, so we got this one. Okay, so we can say the root is in, we update this value 1.02336 0 and 2. Okay, so again, we can go for the next iteration. Okay, so let us go for the another iteration. So we can have x2 is equal to. So we got here a 1.02336 into. This is going to be f of 2. So it is going to be 11.7781112 minus 2 into. This is minus. This is going to be 0.152471. Okay, and this term divided by 11.778112 minus of minus 0.152471. Okay, that's what we can have. So we get the value of x2 here. So we can get the value of x2, and hence we have to think of what is f at x2. Okay, so what is the value of x2 we are getting?
1.035841.
1.035841. That's good. Okay, others please put your values in the chat so you can compare. Okay, or if you are happy with the same answer, then no need to put in the chat. Okay, so now we have to calculate what is the function value at this point. So the function value at 1.035841. So we can calculate this value 1.03584. Okay, so let's calculate, and it's going to be 1. Okay, so yes, so we can get this value as minus 0.081544. Are you getting this value? Yeah, if you are getting anything different than this, then you can tell me. Okay, otherwise we can go ahead. So we can say here, okay, the root is in. So now compare this value. This is minus 0.15 and this is minus 0.08, which is closer to 0. So can I say that the root lies between 1.035841 and 2? Is this statement okay?
Yes, sir.
Okay. So once we get this one, then we can calculate the next approximation. So we can have here, this is going to be 1.0358441 into, this is going to be 11.77112 minus, so we have 2 into minus 0.081544 upon, we can have 11 point, this is 778112 minus 0.081544, and here we can have the value x3. So we can see the example, we want to find the answer correct up to 3 decimal places. Okay, but we can see that we have matched 1.0. Okay, so we have not even matched 2 decimal points after the two values after the decimal point. So we got one value matched after the decimal point, that is 1.0. So let us see what this value is going to be. So x3, you please give me what is the value of x3.
1.04
1.04
2470.
2470. That's good. Okay, so we can have f of x3. So we can think of f of 1.042470. Okay, so we can calculate 1.042470. Okay, so let's have this is going to be minus 0.043332. Okay, and again it is less than 0. So are you getting the same value? So is this statement okay? See, this value is closer to 0 as compared to the previous value. So you can see the previous value was 0.08, and now the value is 0.04. So 0.04 is more closer to 0 as compared to 0.8 or 0.08. Okay, so we have to update the value of A. And once we update the value of A, then this is the interval that we can have. So once we have this interval, we can calculate the next iteration. So we can have this is 1.042470 into 11.778112 minus is going to be 2 into minus 0.04332. Okay. And here we can have this is 11.778112 minus of 0.0433 and 32. So we can calculate the value of x4, and hence we can have what is the value of x4. So we can calculate f of x4. So we can have f of 1.0 something. What this value is going to be? What is the value you are getting?
1.045979.
1.045979. Is that okay? So 1.404579. So let us calculate the value of the function. So 1.045979, and that's what we can have. Yes. So it is minus 0.02. Yeah. 29 and 51. So again less than 0. So compare this value. It is 0.04 and this is 0.02, which is closer. So can we make the statement that the root is in 1.04597922. Okay, now see whether we have reached to the accuracy or not. So earlier it was 1.042. So now it is 1.045. So we have to go for one more accurate digit because we need at least 3 digits. Okay, and hence we can go for the next iteration. Let us see what we get in next iteration. So we can go for x5. So x5 is going to be 1.045979 into 11.778112 minus, this is 2 into minus 0.02295 upon, you can have This is 11.778112 minus 0.022951, and have the value of this x5. So what is the value of x5? 1.04 and some more.
1.047835.
7835. Okay. So you can see two digits are matched. Okay, we have to match
Sure.
one more digit. And now we can calculate the value at this x5. So we can
Sir,
have,
can you please scroll up a little?
yes. Okay.
Yes, sir. Okay, sir. Thank you.
Yeah, welcome. So this is going to be 1.047. So earlier it was 0.45. So now it is 0.47. And this is 835. So we can have this value. Okay. 1.047835. Okay. So we can have this is 0.01. Okay. 2128. Okay, so you can see earlier value was 0.02 and now the value is 0.01. So again, this is less than 0. So we can say here, okay, the root is in 1.04783522. Okay, so accuracy is not at match. So we have to go for one more iteration. So x6 is equal to, we can have 1.047835 into 11.778112. This
Excuse me,
is
sir.
-2. Yes.
Sir, the value of x5, I'm getting different.
Okay. How much different you are getting?
Sir, I have written in the chat box 1.0400.
1.400. Okay. So can you check your calculation once again?
Yes, I'm checking.
Yeah, please. I hope any calculation mistake that can be eliminated if there is any error. Please use the sign also, so you will not have any problem. Okay, or you will get the correct answer. So that's why if you write everything properly, then definitely you will not miss any calculation and you will get the correct answer. So I hope you will calculate this value correctly, x6. So can any
So 1.048813.
8813. Okay. So f of x6. And so we can calculate, and then we can have 1.04. So earlier you can see it was 0.47. Now it is 0.48. So may possible in the next iteration we can get it correct. Okay, so 8813. And you can see the value is going to be minus 0.006. Okay, 413. Okay, which is less than 0 again. But you can see as compared to this value is more closer. Okay, and so
Sir,
the
scroll up a
yes,
little.
yep. Okay,
Yes.
so we can say the root is in the interval 1.04881322. Okay, and hence we can have the next iteration x7 is equal to, so you can have 1.048813 into this is 11.778112 minus, this is 2 into point minus, yeah, so this is minus 0.006413, and here we can have, this is 11.778112 minus of minus 0.006413. I hope here you will get the answer. So we can have x7 is equal to, so it is 1.04 is matched. So now we have to think one more digit, that's it. So what is the value you are getting here?
Sir, 1.049330.
9330. Okay. All of you are getting the same value?
So can you please scroll up a little?
Okay. Is that sufficient?
Yes, sir.
Okay. So all of you are getting this value 1.049330.
Yes, sir.
Okay. So the value at f of x7 is equal to minus 0.003389, which is less than 0, and it is closer to this 0 than the previous value. Okay, so we can say here, hence we can say the root is in 1.04933022. So we have to go for x8. Okay, so what is going to be x8? So x8 is 1.049330 11.778112 minus, this is 2 into minus 0.003389, and here you can have 11.778112 minus 0.003389. So we got here the value of x8. So what is the value of x8? 1.04 is already matched. Okay. So next iteration, what is the value you are getting here? I hope here you should get the value. Anybody getting the value here?
960343.
It is going to be 1.4963. Okay. So all of you are getting this value?
Yes, sir.
Okay. So you can see now for x7. Okay. So it was 0.049. And here it is 1.049. Okay, so we can see the 3 digits after the decimal point are matched, and hence we can stop here for this example. Okay, so what was our example? Correct up to 3 places of decimal. Okay, or 3 decimal places. See, the question is we have to find a root correct to 3 decimal places, and here we got the 3 decimal places. But you can see for this accuracy 10 to minus 3, we have to calculate nearly 8 roots. Okay, and hence we can say the approximate value. Okay, so the approximate root of given equation is x is equal to 1.049. Okay, correct up to 3 decimal places. Okay, so this is correct up to 3 decimal places. Is there any doubt in this example?
So this was
No,
very
sir.
laborious.
Yes.
This was very laborious.
Okay. Is there any doubt?
Sir,
Yes.
sir, when you will be showing us marks?
So we have seen the Newton-Raphson method, as well as we have seen the Regula Falsi method. Now let us think of the next method to solve the transcendental equation, and that is the secant method. Okay, so let us think of this one, secant method. I hope all of you are able to see this, right?
Yes, sir.
Yeah. Okay. So we go with the next method. Okay. So we go with the secant method, right? Okay. So what are the preliminary conditions required? So we consider let f of x equal to 0 be defined in the interval x0 and x1. Okay, so instead of a and b, now I'm using x0 and x1. Okay, then with the condition with f of x0 into f of x1 is less than 0. So the product is going to be less than 0, means either of these two is going to be less than 0 and one is going to be greater than 0. Because if both are positive, then the product will be positive. If both are negative, till the product will be positive. So that means one of this value is negative and other is going to be positive. Okay, then we have, so what we can have is the next iteration x2 is given as x1. We can write here, this is equal to x0 into f of x1 minus x1 into f of x0. And here we can have f of x1 minus f at x0. Okay, and it is assumed that the sequence x0, x1, x2, so on, this sequence is a conversion and it will converge to the root. Okay, so what we have to do is, first we have to consider x1, x2, then we have to consider x2, x3, then we have to consider x2, x3, and then we have to consider x3, x4, and so on. Okay, so here we don't have to think of much about the interval, but we have to go on updating the recent two values. Okay, so first I'll consider x0 and x1. This will be our first iteration. So this is the first iteration which will give you x2. Then we'll consider x1 and x2. This will be the second iteration which will give you x3. Then x2 and x3. This will be the third iteration. Then once we get x2 and x3, we will go for x4, and this will be the fourth iteration and onwards. Okay, so this is the approach of secant method. Okay, you got the idea of secant method. See, we have two values x0 and x1 always, because we'll try to find out where the root lies. Okay, so the root lies between x0 and x1. Okay, and once we know the root lies between x0 and x1, then we'll try to find out the first approximation. So here first approximation is x2. Okay, so what we'll do is we'll discard one value, okay, from the previous interval, and then we'll go for we'll form the new interval. Okay, x1 and x2. So obviously x2 is in between x1 and x0. Okay, so how it will look like? See, we'll have the interval. This is x0 and this is x1. Okay, now x2 will be somewhere here. Okay, so first we were considering this interval, and now we'll consider this interval. Okay, then we can have x3 somewhere here. So next iteration will see, the first interval was x0, x1. The next interval is x1 and x2. Okay, the next interval will be x2 and x3, and so on. Okay, so this will be, all intervals will be the nested intervals. Okay, this all interval will be the nested intervals. And when you have all the nested intervals, then there is a Cantor theorem that it will approach to one point. Okay, so when we have the nested intervals, okay, then their intersection of this nested interval will approach to one point, and that one point is our root. Okay, so that one point is going to be our root. Okay, so you got the idea about the secant method. Have you got the idea about the secant method? How it will work? Yes.
What is meant by nested interval?
Nested intervals, yes. So nested interval means what? See, for example, we have the interval from 1 to 2. Okay, this is the initial interval that we'll have. This is our x0, and this is our x1. Okay, so we know the next value of x2 will be here somewhere. So for example, x2 is in between this 1 and 2. So what can be the value? For example, we take 1.2. Okay, so our initial interval was 1 and 2. The next interval, anything you choose, either it will be 1 to 1.2, okay, or it will be 1.2 to 2. Both of these intervals are here. Is that okay?
Yes.
Yes. Okay, so next you choose, okay, x3. So what are the chances x3 will be here or x3 will be here, right? Okay, so what we have the interval 1 to 2, then we got the two intervals. Okay, so it is 1 to 1.2, and it is 1.2 to 2. So both the intervals are here. Next, this is due to x2. Now, when we choose x3, so either x3 will lie here or x3 will lie here. Okay, so that means here you will have x3, or here somewhere you will have x3. And if x3 is here, for example, okay, so this is going to be 1.8. So this interval will be divided into 1.2 to 1.8 and 1.8 to 2. Or if x3 is here, 1.5, 1.15. Okay, so this interval will be divided into two parts. 1 to 1.15, and this is 1.15 to 1.2. So this further, this interval will be divided into two parts, or this interval will be divided into two parts. But if you see, these all intervals are here only. As these two intervals were here, so these two intervals are here. This interval is already here. So that means you will have this kind of structure. Is that okay?
Yes, sir.
And this is called nested intervals.
Yes, sir. Thank you.
Welcome. Okay, so you will have all the nested intervals, and by Cantor's theorem, okay, so this intersection guarantees a single point, and that single point is going to be our root. Okay, so we are finding that root, and this is the approach of the secant method. Okay, so is there any doubt in the secant method? Is there any doubt in secant method now?
No, sir.
Okay, so you got the idea of secant method? Yeah.
Sir.
Yes, that's good. Okay, so let us try to solve one problem using secant method. Okay, so we'll go for the next equation. Yeah, we'll go for example. Find the approximate root of x cube minus 3x plus 4 is equal to 0 using secant method. So we'll use secant method. So let us try to understand this. So what we have here, let f of x is equal to x cube minus 3x plus 4 is equal to 0. Okay, this is the function given. Now, what we do the next? Okay, B, the given equation. So we find what is f of 0. So what is the value of f of 0 here?
4, sir.
4.
Is going to be 4, right?
Yes.
Okay. So we have f of 0 is equal to 4. What happens to f of minus 1? Because this is positive, so I'm going back. Okay. So f of minus 1 is
0.
Is going to be,
No.
it will not be 0, no?
Yes, sir. It will not be 0.
So it will be minus 1 plus 3 and plus 4. So it is going to be 6. What will be f of minus 2?
Yes.
What is the value we are getting here?
2.
It's going to be 2. So then 4 and 6, this 2 is going to be closer to 0, right? Okay. So what is f of minus 3?
Minus 14.
is going to be minus 14. So we are done. Okay, you can see this is greater than 0, but this is less than 0. So what we can say is the root is in minus 3 to minus 2. Please write the interval properly. Smaller number first and then bigger number. Okay, so when we write the interval A to B, we always assume that A is less than B. So this is the notation for the interval we usually use. Okay, so now we got the idea that where the root is. Okay, so 0, it was not there, it was positive. So we moved back to find out whether we get somewhere negative or not. But for minus 1, again, we got the positive. But for minus 2, we got 2, which was closer than minus 1. And then for minus 3, we got minus 14, so which is negative. So one we got positive, the other we got negative. So we can say what we get here. So here x0 is, so this is x0 minus 3 and x1 is minus 2. Okay. So now we can write by secant method. Okay, so we have what we have by secant method. X2 is equal to what we know. See the formula. So it is x0 f of x1. Okay, so we got here. This is x0 f of x1 minus x1 f at x0. And here we got f at x1 minus f at x0. So we can have these values here. So x0 is minus 3. So that is minus 3. Then f of x1. So x1 is minus 2. So that is going to be 2 minus x1 is minus 2. Okay. And then what we got here? F of x0. So it is minus 14. And this is going to be 2 minus minus 14. Okay. Is that okay? Are you getting this?
Yes, sir.
Okay. So we can calculate the value of x2. What is the value of x2?
Minus 2.125.
Minus 2.125.
1, 2.
125 is correct?
Yes, sir.
Okay. So we calculate what is the value at f of x2. Okay. So calculate the value of f of x2.
So 7.2207.
It's going to be 7.2270.
2270.
Okay.
2207. Sorry.
Okay. Is it positive?
Sir, the answer is the calculation mistake I have done. Sorry.
Is that okay?
Yes, sir.
Yes, sir.
Yeah. Okay. So what we can say is, so here, once you know the initial first approximation, so what you have to do next, we have to go on updating this. Okay. So what we'll be having next? So we have x3 is equal to, so you'll be having x1 f of x2 minus x2 f of x1. Okay. And what you'll have here? F of x2 minus f of x1. So what we did here, update the value of x0, okay, to x1 means what? X0 here x0 becomes x1 now, okay, and update the value of x1 to x2. Okay, so x0 is replaced by x1 and x1 is replaced by x2. Okay, so that means we have to remove x1 and we have to we have to remove x0 and we have to consider the interval x1 to x2 now. Okay, that's why it becomes the nested interval. Okay, and so we have all these values now. Okay, so let us calculate this. So what you got here? X1. Okay, so what is the value of x1? Is it -2? X1 is going to be -2, no? So x1 is -2. So that is -2. F of x2 is going to be 0.779296. Okay. So I'll write it here. So it is -2 into 0.779296 minus x2. x2 is -2.125 and f of x1. So f of x1 was 2.
The x2 will be -2, right?
Wait. Yep. Okay.
So x2 will be
Wait.
-2.125.
Yes, just wait. Okay. So here we have to update this. Okay. So we have x1 already, we have decided this, no? Okay, and then we are having x2. Okay. So don't get confused here. Now, once we have started with this algorithm or with this, then we don't have to think or about the interval. Okay, now x1 will be, as I have drawn that earlier, once we have x0 and x1, we are able to get x2. Once we get x2, then we have to use x1 and x2. Then once we get x3, we have to use x2 and x3 and so on. Got it? Are you getting this? Or you want to go with that interval kind thing? Okay, so if you are going with the interval, then we have to write it like this. So every time then you have to write with the interval. Okay, so there will be no difference in calculation. Okay, so we can say the root is in -2.125 and -2. Is that okay? Are you getting this? No, this is positive, no? So the interval will change. If you go with the interval, it will be in like this, right? Is that correct? Are you getting this?
But -3 will be x0.
Yes, that's why I was saying that we have to update x0 to x1 and we have to update x1 to x2. This is the difference in approach of secant method. That's why it is going to be the secant method. Got it? So if you think of the interval, then it is not going with the interval, it is going with the nested intervals. Okay. So if you go with the interval, it will be like this. and that's why we have to go with the next iteration. Okay, so what will be the next iteration? By secant method, we have x3 is equal to, okay, so x3 will be x1 f of x2 minus x2 f of x1, and here we'll have f of x2 minus f of x1. What this one? Okay, so we have x1 remains x1, but we have to introduce x2. Okay, and hence we can have x3 is equal to, so our x1 is minus 2, f of x2 is 0.779296 minus x2 is minus 2.125, and f of x1. Okay, so f of x1 is 2. And now we have to think this 0.779296 minus, we got here, this is going to be 2. Okay, now calculate the value of x3 and give me the value of x3. What is the value of x3 we are getting?
Minus 2.20479.
This is going to be minus 2.20479
479.
999. Okay. So calculate the value of f of x3 now. So is it coming to be minus 0.103436? Is that okay?
Sir, 46.
1034.
Yes, sir. 46.
And the last.
466.
Okay. Please check once.
3446.
46.
Okay. 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 Zero, 4, 7. This is 0.1034. You got 6 here. What is the value you are getting? F of x3?
0.103446.
3446. Okay. This is what you are getting, right?
Yes, sir.
Okay. So you can see earlier it was positive. Okay. For x2 it was positive. For x3 it is coming to be negative. Okay. So you can see it is jumping on the positive negative side, and it will approach to 0. Okay. This is how the secant method will work. So next iteration we have x4. So what will happen now? Okay. So update x2, x1 to x2. Okay. We'll update x1 to x2 and x2 to x3. Okay. And then once we have this x2, x3, we are able to find x4. So what will happen here? It will be x2 f of x3 minus x3 f of x2. And here we'll have f of x3 minus f of x2. Okay. So calculate this value. x2. What is x2 we have? So x2 is minus 2.125. Okay, x2 is minus 2.125. F of x3 that we have calculated here minus 0.103446 minus x3. So it is minus 2.204799. And f of x2. F of x2 we have calculated. So it is 0.779296. This is going to be 0.7792. Okay. 9296. Okay, and here we got this is f of x3. So it is minus 0.103446 minus 0.779296. So we calculate x4 here. So calculate what is x4. This will be minus what is the value you are getting? What is the value of x4 you are getting here?
Minus 2.195447.
2.195447. Okay, so f of minus 2.195447. So that's what we have to calculate. Okay. So is it coming to be 0.004313? Is this a value correct? If you are getting something else, you can tell me. Is this value correct?
Sir, I am getting 0.004307.
4307. Okay. And that's okay. 4307.
Sir, I am getting
Yes,
this one.
sir, same one. This one.
4307, right? Okay. So you can see this value is very closer, okay, to 0 actually. Okay. So as compared to this value is going to be very closer. So we have, okay, one more iteration will go. Okay. So we have x5 is equal to. So now what will happen? We have to use x3 and x4. So x3 f of x4 minus x4 f of x3. upon we'll have f of x4 minus f of x3, and that's what we have to calculate. So let us calculate this one, x3. So what is going to be x3? So it is minus 2.204799. Okay. Then f of x4 0.004307. Okay. Minus, you can have x4. So it is minus point. This is going to be minus 2.195447 into f of x3. Okay, so that we have calculated. F of x3 is minus and we can write here. Okay. Okay, so we can write x5 is equal to x3. There's going to be x3 is minus 2.204799 minus 2.204799 into f of x4 0.004307 minus this x4, so minus 2.195447 and f of x3, so minus 0.10, what we obtained here, 3446. 3446, and this all term divided by 0.004307 minus 0.103446. Yes. So calculate this. What is the value we have?
So 2.019561.
Positive, negative?
Positive.
Positive, we cannot have positive, we'll have negative.
I'll check.
This is negative. These are three negatives. So numerator is negative, denominator is positive. So we'll get negative.
Minus 2.195040.
195040. What about the others?
Minus 2.195820.
5820. Okay.
Sir, same, sir. Minus 2.195821.
58 you are getting.
5820.
Okay. So most of you are getting 58. Okay. 5820, right?
Yes.
Okay. So you can see the previous value. What was the previous value? Minus 2.1954. Okay, so here we are getting 58. So that means you have reached 10 raised to minus 3. Okay, if you go for one or two more iteration, you will reach to 10 raised to minus 4. Okay, so what we can say here, hence the root of given equation is, okay, x is equal to minus 2.195820. Okay, after 5 iterations. Okay, so as per the question, we have to write, if the question is go for 3 decimal places, then this is correct up to 3 decimal places. If the question is correct up to 4 decimal places or 5 decimal places, as the mention in the question, we have to answer like that. So this we have calculated correct after 5 iteration. Okay, so this root is after 5 iteration. If we go for more iteration, we can get the another one and maybe correct. So now the difference in approach for the previous method and this method. Okay, so in the previous method, we were using the intervals. Every time we were deciding where is the root. Okay. And in this method, we don't have to decide where is the root. We just have to go on iterating. Okay. And we'll reach to the correct root. Okay. So this is the difference in the approach. And that's why when we started with the first iteration and second iteration, you got the difference, what is going to happen or why this is happening. Okay. So here we go on updating the interval automatically. So, and these interval are the nested intervals. So that's why you can understand now the root is it is oscillating between positive, negative, and then finally it is settling. Okay. So it is moving closer and closer, but from both the ends. Okay. So sometimes it is showing positive, sometimes the value is showing to be negative, but it is moving closer and closer to 0. So see, for x2 it was positive, for x3 it is negative, then for x4 it is again positive, and for x5 we have not calculated, but it will be more closer to 0. This is the difference in the other methods and the secant method. So if you have any doubt, you can ask. Do you have any doubt in this method?
No, sir.
Okay, that's good.
Can you please scroll down?
Yes,
Scroll down, sir.
yes, yes. Okay. Is that okay?
Yes, sir. Thank you.
Okay, yeah. Welcome.